Hi, Steve.
Yeah,
Do you
Ning.
see the parking lot light?
Okay.
I wonder if we want to wire up the light, what size conductor we should use.
Well, that's a great question, Ning. And it's a common example for the electricians out there. You go to a job site and the customer says, well, we got these parking lot lights and we're going to install new ones, and you have to decide what branch circuit you're going to run and how many branch circuits. So, Ning, let's just assume that there's going to be 10 parking lot lights. Let's keep it simple. And let's say that each parking lot light is going to be 200 watts each. So we got 10 lights at 200 watts. That's 2,000 watts. You notice I'm not talking about voltage yet. I'm just talking about watts. Okay, really important. So now, lighting is something special. And Ning, what do you think that special thing is about lighting?
Continuous load.
It's a continuous load. That is correct. So we have a continuous load when the maximum ampacity is going to be on for 3 hours or more. So we're going to take that 2,000 watts times 125%. We're going to end up with 2,500 watts. Now, we need to calculate this into amps. We're going to use the pi formula. And P is equal to I times E, where P is equal to power, I is equal to amps, and E is equal to volts. We're going to rewrite the pi formula to solve for I. So I is equal to P divided by E. I is equal to the P, which is now equal to 2,500 watts, divided by the voltage. I didn't give you the voltage yet, but let's say you only have 120 volts available, right? 120 volts available. And when I did my math, we got 2,500 watts divided by 120 volts. That's 20.83 amps. When we look at our ampacity table, table 310.16, we're going to find 10 gauge. 10 gauge is going to be equal for 30 amps under the 60 degree C column. So some of you might be saying, you know what, 10 gauge sounds like a good number. Ning, what do you think? Would most, I wouldn't say most, would some electricians just run 10 gauge and call it a day on this?
Oh, absolutely.
That's right. I would say that some of them would just say it's going to be 10 gauge. But you know what? That could be a problem. And why is that? Because we have to account for voltage drop. It's a real problem that's out there. Because if we've got a long run and let's say those lights are not getting the proper voltage, they're probably not going to work properly. All right, so let's say we have a total distance one way of 500 feet. So let's say we started at that corner of the building, and that's where the branch circuit starts, and then we go down here and all the way around to the other side of the building. Well, let's say that's 500 feet. So when I did this on my voltage drop calculator, and there's plenty that you can find online for your phone, we came out with a voltage drop of 20 volts, which was equal to about 17% of voltage drop. And that's a big number. You probably don't want to go more than 3, 4, maybe 5% maximum voltage drop. So to prove that, you're now going to see on this video, we're going to do a voltage drop formula. Okay, and I'm going to say it and you're going to see it on the screen. So the long formula for voltage drop is going to be VD, that's going to be for voltage drop, is equal to 2 times K times I times D. You take that entire product and you divide it by the circular mils. So when you do all of that math, and again, for our students there, I expect you to go into your code book. You're going to find your circular mils. I'm going to give you a hint. You're going to go to chapter 9, or is there someplace else you can find circular mils? Ning, what do you think? Is it chapter 9?
Chapter 9, table 8.
All right, chapter 9, table 8, that's going to be for direct current, and chapter 9, table 9, that's going to be for alternating current, all right? But go to chapter 9, table 8, you're going to find your circular mils. And if you're not a student of electrical time and you don't know what I'm talking about, don't worry, because at the end of the video, I'm going to give you a way to get you invited to one of our classes so we can do these calculations together. All right, but this class is really for my students that are enrolled in my class, but I'm putting this on YouTube so that other people can see what happens in real life. So when we take that formula, and again, that's VD is equal to the product of 2 times K times I times D, and you divide that whole thing by CM. And when we plug in the numbers into that, we get to an actual voltage drop of 20.7 volts. And you're going to see all of that on the screen here. So I know I'm going fast, but this is a review question for my class. Now, for my students, what I want you to do, I want you in class, after you watch this video, we're going to do the same voltage drop formula with Ohm's law, and that's E is equal to I times R. All right? So for the people that are not my students, you can go to my website, electricaltime.com. I've got free code questions and answers. So just click on the free code questions and answers. Monday through Friday, you'll get a free question and an answer. All right, thanks a lot, and we'll see you on the next video.